Lesson 7.8, found on page 291, requires a little bit of background knowledge, which they give you in the lesson, about the different properties of the operations. And so it's helpful if you understand those properties pretty well. And so I have this chart in the back of my notebook with all the properties and their definitions written down. So I highly recommend that you have the same in yours. All right, so we're going to generate equivalent expressions. The essential question: how can you use properties of operations to write equivalent algebraic expressions? Equivalent expressions are equal to each other for any values of their variables. So any number that you put in for the variable, anything you substitute in for the variable, you're going to come out with the same answer, is what that means. For example, x plus 3 and 3 plus x are equivalent. You can use the properties of operations to write equivalent expressions. So x plus 3, if you substitute it in a 4, 4 plus 3 is 7. 3 plus x, where you flip the two terms and you go ahead and substitute that 4 in, you still come out with 7. So these are equivalent expressions. They equal each other. So that it depends on the properties whether or not that can work. So for example, commutative property of addition. If the order of the terms change, the sum stays the same. So with addition, it doesn't matter which number comes first and which one comes second, you'll come out with the same answer every time, just like up here. That's not true for subtraction. There is not a commutative property of subtraction. It won't work. Then we have associative property of addition. When the grouping of terms changes, the sum stays the same. So in this case, these two are grouped, the 8 plus the b. And over here, the grouping is around the 5 and the 8. But either way, you're going to end up with the same answer. Again, this only works with addition. All right, and then, well, it does with multiplication also, but not subtraction. And then identity property of addition. The sum of 0 and any number is that number. So in other words, anything you add with 0 is going to come out to the same number. All right, those are the properties of addition. Now let's take a look at the properties of multiplication. The commutative property of multiplication: if the order of the factors changes, the product stays the same. So in other words, we can swap d times 9 or 9 times d. It'll come out the same answer. The associative property of multiplication: when the grouping of factors changes, the product still stays the same. So 11 times the quantity 3 times e. And if we move those parentheses over to 11 times 3 times e, you'll get the same answer. And then finally, identity property of multiplication: the product of 1 and any number is that number. So up here it was 0, because when you add anything to a 0, it comes out itself. With multiplication, it's a 1. Anything times 1 is itself. Now, the way I remember which property is which is commutative property. I think, okay, when people commute in their cars to work, they might pass each other. They're getting from their house to their work, and it doesn't matter which car gets there first as long as they get from their house to their work. So I just remember commutative. I remember we can switch the order. They can move around. Associative property, and this goes for both addition and multiplication. I think, okay, who do you play with at recess? Well, one week you might be playing with B, and the next week you might be playing with 5. And so I remember that as grouping, like with our parentheses, and I remember that by thinking about who we play with at recess. So here we're going to have a couple friends playing tetherball at recess. They're associating with each other, but maybe next week you'll play with somebody else. And so this next week you're gonna play football with somebody else. Okay, so associative means grouping. Commutative is switching places. All right, and then identity is just itself. You are yourself. That is your identity. So whatever. With addition, when you don't change anything, you just still are yourself. With multiplication, multiply by 1, you're still yourself. That's your identity. That's how those are my tricks for remembering. All right, here we go. Nelson ran 2 miles, 3 laps, and 5 miles. The expression 2 plus 3L plus 5 represents the total distance in miles Nelson ran, where L is the length in miles of 1 lap. Right? An equivalent expression with only 2 terms. So remember from our last lesson that we learned how to combine like terms? Well, that's basically what we're going to do here. But in order to combine those like terms, we're going to have to move them around. That's all we're doing. That's all we're doing with these properties, is just moving things around and then combining the like terms. All right, so the like terms are 2 and 5 because neither one of those have a variable. Use the commutative property to reorder the terms. So I'm just going to get this 2 and this 5 next to each other so it looks more logical for adding them together. Use the associative property. Property to regroup the terms. So we have 3L, then we bring down the 2 and the 5 again, and the associative uses parentheses. Add within the parentheses, I end up with 7, because 2 plus 5 is 7. So an equivalent expression for the total distance in miles is 3L plus 7. Distributive property is an interesting property. We use it a lot in algebra. Multiplying a sum by a number is the same as multiplying each term by the number and then adding the products. So here's an example. 5 times the quantity g plus 9 is this. You'll get the same answer as if you did 5 times g plus, this is where the plus comes from, right there, 5 times 9. So distributive property can also be used with multiplication and subtraction. For example, 2 times the quantity 10 minus h is the same as 2 times 10 minus 2 times h. Okay, now the way I learned how to do this, and it helps me to remember, is throwing the ropes. So let's rewrite this. 2 times the quantity, 10 minus h. If I throw the ropes into the quantity, that's the same as 2 times 10 minus, that's where that came from, 2 times h. And that's how I remember distributive property, is throwing the ropes into the quantity. Okay, so let's do it. Let's do some more examples here. Okay, use properties of operations to write an expression equivalent to 5a plus 8a minus 16 by combining like terms. All right, so 5a is the same as a times 5. So we'll use the commutative property of multiplication to rewrite those terms. So this is the same as 5 times A, and we just switch their order and move the A in front, A times 5. So this is like 8 times A. So if I switch the order, A times 8, and then minus the 16. Use the distributive property to rewrite A times 5 plus A times 8. So instead of throwing the ropes into the quantity, this time I'm pulling them out. So I have this, and I have this, and I'm pulling the A out front. So A from here and here. A times the quantity, 5 plus 8, because that's what was left over, minus 16. So A times, now 5 plus 8 is 13, minus 16, add within the parentheses, use the commutative property of multiplication to rewrite A times 13, so that would be 13A, because I just switched them again, minus 16. So personally, I think this is much more complicated. It works, but I think it's more complicated than just looking at combining our like terms, which we already know how to do. So let's do this to double check that our answer is correct. So 5A plus 8A is 13A minus 16. Same answer. So we did do it right. Use the commutative property of multiplication. Oh, we already did that. Sorry. So the expression 13A minus 16 is equivalent to 5A plus 8A minus 16. They're the same. You'll get the same answer when you substitute a number in for A. All right, here we go. Another problem. Use the distributive property to write an equivalent expression. So we have 6 times the quantity y plus 7. Use the distributive property. So I'm going to throw the ropes in. So 6 times y plus 6 times 7. Multiply within the parentheses, so I ended up with 6y, that's where this came from. 6 times 7 is 42, so the expression 6y plus 42 is equivalent to 6 times the quantity y plus 7. You'll get the same result when you put a value in for y. So just to prove it to you, let's do that. Let's just put a 2 in for the y real quick here. So, let's see. Let's do it both ways. 6y plus 7. We're going to put in a 2 in for that. 6 times 2 plus 7 is the same as 6 times 9, which is, what, 54? All right, let's do it over here. 6y plus 42. Put in a 2 for that. 6 times 2 plus 42, that's what, 12 plus 42 equals 54. You'll get the same answer. It's just written 2 different ways. All right, 12a plus 8b. So this time we have 2 different variables. So now we have to find the GCF of 12 and 8. To figure out what we're going to pull out and what factor we're going to pull out from both of these. So the greatest common factor, or GCF, of the coefficients of the terms, that is 4. Our greatest common factor is 4. So you might need to remember how to do that. 8 and 12. All the factors of 8 are 1, 2, 4, and 8. Of 12 is 1, 2, 3, 4, 6, and 12. The biggest number, the biggest factor for both of them is 4. All right, write the first term, 12a, as the product of the GCF and its other factor. So 12a is the same as 4 times 3a, right? Because 4 times 3 is 12. And then we kept the plus 8b, but now we're going to do that to the 8 also. So 4 times 3a, that's where this came from, times, plus 4 times what's left over. If I pull a 4 out of that a, 2 is left over, right? 2 and the b are left over. So now I can throw the ropes outside, and that's where that came from, the 4. And what was left over? The 3a plus the 2b was left over. So 4 times the quantity, 3a plus 2b. All right, here we go. So the expression, 4 times the quantity, 3a plus 2b, is equivalent to 12a plus 8b. In other words, if I put in a number for a and a number for b, in both of these expressions, I'm going to end up with the same number, the same answer. Okay, let's do 2 more together before I cut you loose. All right. 3.7r minus 1.5r. Well, the easiest way to do this, since we have like terms, they have the same variable, would just be to subtract. And I'd end up with, bring down that r, 2. So the answer would be 2.2r in this case. We don't really have to use the properties of operations. Now here we do, because our like terms are separated. So the first thing we're going to do is swap these two, their order. We're going to use commutative property of addition. 20a plus 16a plus 18. So they're all the same terms. I just switched places. Now I'm going to group these two. 2a plus 16a is 18, or I'm sorry, that's 20a. I'm sorry. 20a plus 16a would be what? 36a plus 18. All right, so you're going to do the same thing with these, swap them around, get the like terms next to each other, then simplify. Okay, good luck. Let's take a look at our note. Okay, so my notes are on page 135 of my notebook. That's what I referred to at the very beginning. This whole set of properties, including the distributive property, identity of multiplication. I also put all the symbols. So of each of these operations, that's our addition symbol. There aren't any other ones, but with multiplication, they have lots of different symbols that indicate we're doing multiplication. And finally, distributive property, we use both multiplication and division. And then I wrote the definitions inside, just so you can see a few of them and my little tricks. Okay. So, commutative property, we can move and trade the terms. Remember, like the cars, they can just trade places. Associative property, who are we playing with at recess? We're grouping, and we can change the grouping order. Distributive property, throw the ropes or pull out the GCF. So, distributive property into the quantity, throw the ropes. So this 2 is going into the quantity. I'm throwing the ropes in. I end up with 2 times 3, 2 times a. So I end up with 6 plus 2a once I multiply the 2 and the 3 and the 2 and the a. Or this one where I am pulling the number out of the quantity. I have to find the GCF first. So I use the same numbers. I'm just doing it backwards here. The same factor comes out, the leftovers stay in the parentheses, and that took me back to 3 plus a. All right, good luck.